everyone, this is Mr. Chang, and in this video, we're going to take a look at the NPC Dialog Box, as well as math.random, math operators, and string concatenation in Lua. The dialog object allows users to create NPCs, also known as non-player characters, that players can talk to. In our case, we're going to use the dialog object to display the answers to our math problems. So to do this, go ahead and inside of Roblox Studio, in the whiteboard that we created before, we're going to go ahead and we're going to add a dialog object. I'm going to add that right over here. And we're going to have some output, which we're going to code in a few moments. Now, to create our math problems, we're going to use random numbers. Random numbers play a key role in computer science, from cryptography to gaming. And inside of Roblox Studio, we have a function called math.random. Math.random returns a number from the starting number to the ending number, inclusive of both of those numbers. The math operators in Lua are pretty familiar from math. We've got plus and we've got minus, which is the same. Multiplication and division are a little bit different. So multiplication, we've now got the asterisk or star. Division, we have the slash. For the exponent, we have the caret symbol. And the modulus operator, which I'll go over in a few moments, is the percentage sign. That is the remainder after integer division. Now, let's take a look at addition. So inside of Studio, I'm going to go and type out these commands via the command bar just to kind of test them out. So I've got print, and I'm going to use addition here. So I've got print 10 plus 32, and I've got an answer of 42. And next up, let's look at subtraction. So I'm going to do 32 minus 33. So let's do 32 minus 33. And just as we expect here, we've got -1. All right, let's take a look at another problem. We've got multiplication. So let's try 12 times 12. So again, back in Studio, I'm going to go 12 times 12. And just as we expect, again, we've got 144. Now let's test out division. So we've got 22 divided by 7, which is a approximation of pi. So let's see how many digits we get here. So we've got 3.14, 285, 14. So we've got a whole bunch of digits here. And that is division. All right, now next up here, let's take a look at the modulus operator. So let's look at 11, and how we call it is 11 mod 2. So if you think back on division, let's say we have 11 divided by 2. This may look a little bit familiar to you from when you're doing math a long time ago. So at a certain point when you're dividing, your teachers would tell you about the remainder. So let's say we have 11 divided by 2 would be 5, is like the whole number there. And then the remainder is 1. So you would have something like, let's say 5, big R, and then 1. At a certain point, your math teachers probably told you to put a decimal point and keep doing long division, and you might have forgotten about the remainder. But in computer science, the remainder will be very useful. We'll kind of see it inside of problems in the future. Now, again, to wrap your head around this, the remainder is kind of like 5 times 2, because we were dividing by 2, so we've got 5. So 5 times 2 is 10. The remainder is 1, so 5 times 2 is 10 plus 1 is equal to 11. So again, if we go into Studio, let's go over here, and I go back to my 11 modulus 2 here. The answer that we get down here is 1. All right, the next thing we're going to look at is operators precedence. So precedence is the condition of being more important than, let's say, somebody else, or having a different rank or order, etc. Now, in programming, what this means is which operation is performed first. So this is the operator precedence chart. And let's kind of go through this. It's kind of like a variation of PEMDAS, except for programming and a little bit more detailed. Now at the very top, we've got exponent. So that goes first. Then we've got the not, which we'll look at in the future. It's kind of like negating a value, for instance, like negative number. We've got multiplication division. Again, reminiscent of like PEMDAS here. We got addition and subtraction. Then we've got string concatenation, which we'll look at a little bit in this lesson. We've got relational operators, which we'll look at in the future. And then we've got the logical and or, which again, we'll look at in future lessons. So suppose we had the expression of, let's say, 3 plus 2 times 10. Thinking about which would go first here, again, per our operator precedence chart, we have 23. We know that the 2 times 10 gets evaluated first, and then we add 3, and that's how we get 23 here. So again, by the chart here with precedence, we know that the multiplication goes first. So it's kind of the equivalent of putting the 2 times 10 together. That means that it would definitely go first. Now, associativity is the order that operations with the same precedence are performed. Now, for most operations, the operations go from left to right, kind of like the way we read in English. And that's called left to right associativity. However, there are some operators that perform operations from right to left, which we'll look at in my chart over here. So again, most operators go from left to right. For example, our multiplication division, we've got addition and subtraction, but there are some that go from right to left, and those include the exponents, the not, the string concatenation are just some of the ones that go from right to left. Now, what exactly does this mean? So let's just take, for example, here. We know that with addition and subtraction, it goes from left to right. So if we have, let's say, 1 plus 2 plus 3, what that means is the equivalent is with left to right associativity is that we can actually put a parentheses around the 1 plus the 2. It would be the same value. Same thing with multiplication, again, going from left to right. We have 4 times 5 times 6. 4 times 5 would go first, and then 6 would be multiplied afterwards. Now, what about right to left associativity? Because that's kind of the opposite of the way that we read. And again, some operators are operating from right to left. So let's say, for example, we had 2, and then we have the exponent 3, and then we have the exponent 4. Now, because exponents are going from right to left, again, we can kind of put the parentheses around this because that's the way it's being evaluated. We would have 3 to the 4th, and whatever value that is, we would have 2 to the power of that. And that is what right to left associativity means. Now, when in doubt, though, if you get some really complex expressions that you create, my advice is to just use parentheses. It's a little bit easier than remembering the precedence and associativity chart than trying to like figure out which one goes first, etc. Just use parentheses. It'll make your life a little bit easier. Now, let's go ahead and create some random math problems. And to do that, let's go back into our Roblox studio, and let's go ahead and let's create a script here. So we're going to create a script, and let's go ahead and write some code here. So we've got local whiteboard equals scripts dot parent, and then we're going to have our text label, and we're going to set that to our surface GUI. Okay, so this first line over here is just our part. This is the text label that we added before. Now, I'm going to add this code of weight 10 because we already have a message on our whiteboard, and it does take some time to kind of run around it. So this statement here is telling Roblox Studio to wait for 10 seconds just so that we can kind of run around inside of our game to kind of see it change from let's do some math to the math problem that's going to be randomly generated. Now, let's go ahead and create two operands for our math problem. Let's go ahead and create random numbers from 1 to 100. So let's call this local operand 1 equal math.random 1 to 100. And let's make another one. So we've got math operand 2 equal math.random 1 to 100. So now we've got two random numbers, which we're calling operand 1 and operand 2. Now, the next thing we're going to do is let's go ahead and assign the variable answer to the answer of the addition of operand 1 and operand 2. So let's go ahead and type local answer equal operand 1 plus operand 2. All right, now next thing we're going to do is we're going to display the math problem on our whiteboard. And to do that, we're going to set the text property, which we initially set inside of properties, but now we're going to change it by code after 10 seconds. So let's go ahead and change it. So we've got text label dot text equal operand 1. And here we're using the ... which is string concatenation. And we're going to say operand 2. And let's go ahead and add a question mark there because we're trying to ask the user what the answer is. And again, just to recap from a previous lesson, to combine strings, we use string concatenation. String concatenation is kind of like a fancy word for combine. And in Lua, string concatenation is the ... there. Now, to display the answer in the dialog prompts, when the user clicks on the question mark, we're going to add this line of code here. So let's go ahead and add down below. We're going to add whiteboard dialog initial prompts equal the answer is, and we're going to put that value of answer that we calculated right up here. So let's go ahead and run our code and see what happens here. Go ahead and click on play here. And let's run around to the front here. So we've got let's do some math. It's waiting 10 seconds. And so we've got 55 plus 56. I wonder what that is. I think that is 111. So let's go ahead and click on the question mark here. And the answer is 111. All right, let's try this again. So right now our code isn't that sophisticated. We do have to keep running our playtesting our program in order to see some new math problems here. So now we've got 43 plus 40. I think that is 83. All right, we've got 83. That's good. And I'll do it one more time here just to see our random numbers being created. And so let's run around again. Wait our 10 seconds. Waiting. And we've got 80 plus 51. I think that's 131. And the answer is 131. All right. I hope that helps, and I'll see you in the next video.